Introduction to Neural Networks with C#, Class 3, Part 3. Welcome to Part 3. In this part, you will see how to use the Hopfield neural network classes that you just created in the last part in a simple console mode application. The console mode hides a lot of the details that you might see in a GUI application and allows us to focus primarily on the subject of this course, which is neural network programming. In the next part, we will look at a more advanced example that does make use of the GUI. We begin by looking at the structure of this console mode application. The console example begins by creating a Hopfield neural network named network. As you can see, a 4 is passed into the constructor to indicate that there will be 4 neurons. Next, we create 2 input patterns, pattern 1 and pattern 2. Pattern 1 is the input pattern that the neural network is going to be trained with. So we're training it to recognize true, true, false, false. Pattern 2 is the pattern that is the distorted pattern that we're going to present to the neural network to see if it can recognize it. It should recognize that this is pretty close to pattern 1 and produce pattern 1 as the output, meaning that it has recognized pattern 1 to be essentially the same as pattern 2. We have also a Boolean result, which is going to hold the result. That is basically going to be the output pattern that was in fact recognized. We begin by displaying the pattern that is going to be trained. This is pattern 1. To display the pattern, we use the format Boolean function. This function was defined earlier in this class. All that the format Boolean function does is displays trues as t's and falses as f's. This simply displays the pattern so that it is displayed to the console. Next, we train the network for this pattern, pattern 1. By calling the train method on the Hopfield neural network, the Hopfield neural network is trained for this pattern. Here you see pattern 1 being presented to the neural network. Pattern 1 is what the neural network was trained with, so it should echo back pattern 1 as the output. We display that we are presenting pattern 1, and we display the output to the console screen. Next, we present pattern 2. We should get pattern 1 back for presenting pattern 2, because the neural network should recognize that pattern 2 is actually close to pattern 1, and it's only been trained with pattern 1, so naturally that is what it feels that it is a close enough match to. Now let's watch this application in action. We set a breakpoint to stop the application so that we can actually see the console output. This is necessary in C#. There's other ways to do it, but this way works. Here we see the output. You can see what we trained the neural network for, true, true, false, false, and we see the results of presenting the neural network with each of the 2 patterns. Presenting it with the slightly altered pattern resulted in pattern 1 being recognized. Now let's look at a slightly more complex example. Here we see an application that allows you to input a pattern into a 4-neuron Hopfield neural network. This is the same format neural network as we saw before, a 4-neuron Hopfield neural network. You can see the weight matrix though. It's initially set to all zeros. You're allowed to input a pattern that the neural network will be trained for. Basically, you input the pattern, click the train button, and the weight matrix will adjust. You input a pattern and click run, and the weight matrix will be given a chance to produce the output from the input that you've presented to the Hopfield neural network. You can also press the clear button, and it will clear the entire weight matrix and reset it to an initial state. Now let's take a look at how to train this Hopfield neural network in this application. Now let's make use of the C# application. Here we set from 1, 0, 1, 0. This is the pattern that we're going to train it with. It's going to be trained with 1, 0, 1, 0. We click train. It is now trained. Now we're going to see what happens when we present a pattern. We're presenting the exact same pattern that it was trained with, and we notice that the output is the same pattern. it has successfully learned the pattern that we have trained it for. We can also present other patterns that are close to this pattern. Let's go ahead and input 0, 0, 1, 0, which is close, and you'll notice it still recognizes it. The yellow value represents where it had to change the value slightly. Now we're going to see a Hopfield neural network that actually recognizes a graphical pattern. Here you see another application. This application has a grid. On this grid, you can draw individual items. By clicking on a box, the box will either turn on or off. It toggles. You can draw patterns onto this grid and click Train. The neural network will be trained for the pattern that you drew. You can also click Go, and the neural network will attempt to recognize the pattern that you just draw. Clear will clear the entire grid of any drawings that you had made before. We're going to now take a look at how you can train this Hopfield neural network for two patterns. The Hopfield neural network will then be able to recall either of these patterns when you draw either all or part of one of these two patterns. We're going to show you how to train this neural network for this now. Now let's make use of this C# application. We're going to draw the first pattern in the upper corner. This is a simple rectangle. We click Train. The neural network is now trained for this rectangular pattern. We can remove part of it and click Go, and you will see that the neural network still recognizes the pattern. Now let's erase the pattern and create a second pattern. We're going to train the neural network for that pattern. It's now trained, and we can remove part of that, and we can see that it recognizes it. We can also delete that pattern and draw part of the first pattern and see that it recognizes the first pattern. This neural network has now been trained for two patterns. They have been drawn separately, but it recognizes them independently. This concludes part 3. In the next section, we will continue past Hopfield neural networks and learn some training methods that will form the foundation for more complex neural network types that we will see later in this course. We will also look at error calculation, which is an important concept for training neural networks. We hope you will continue with class part 4. This course is based on our Introduction to Neural Network Programming books for Java and also Introduction to Neural Networks for C#. Available in both paperback and ebook format.